Good day and welcome again to another recording on a GCSE Edexcel higher tier walkthroughs of maths. This is paper 1 from November 2020. This is still COVID era. This one I do believe would have been scheduled for May of 2020, but because of a pandemic was basically scrapped and put onto the November reset rota. So I'm going to talk you through the questions. I'll mention a few different methods for some questions, not for all, because I have been told my videos are if anything, my videos are already too long. So I'm not going to make them any longer, but at the same time, I don't want to make them so short that I skip out important ways of explaining things. So if you do get an answer which is the same as what I've got here via a different method, you can assume that your method is almost definitely correct, but do let me know in the comments or elsewhere if you want me to check through. So that's enough from me. Let's get straight into it. Let's have a look at question number 1. We've got the first 5 terms of an arithmetic sequence here. 1, 4, 7, 10, 13. Write down, in terms of n, what the nth term is. So arithmetic means these terms are going up by the same number each time. As you can see, they're going up in 3s each time, just like the 3 times table. Because they're going up in 3s, we write down that it's got something to do with 3n. 3n is the 3 times table. So what we could do, one method, is write down the 3 times table below our sequence. 3, 6, 9, 12, 15, and so on and so on. Our sequence is lower, obviously. 1 is lower than 3, 4 is lower than 6, and so on. How much lower is 1 compared to 3? Obviously, all these numbers are 2 lower. So this sequence is like the 3 times table, but it's 2 lower than the 3 times table. So it's 3n minus 2. Question 2, it says show that 2 1/3 times 3 3/4 equals 8 3/4. Well, sometimes to show something's true, the best thing to do is just to do the calculation. So first of all, what we need to do if we're multiplying 2 fractions together is change them into top-heavy fractions first. So what we do, we take the whole number, multiply by the bottom, and then add on the top. So 2 times 3 is 6, plus 1 gives us 7. So we're going to have 7/3. This one, in the same way, whole number times by the bottom number, then add on the top. 3 times 4 gives 12, plus 3 gives 15. So now we perform the multiplication with these values. So to multiply 2 fractions together, we do the tops multiplied and also the bottoms multiplied. So 7 multiplied by 15 and then 3 times 4. Well, 3 times 4, that's easy, that's 12. 7 times 15 is a bit harder. You might even want to do it using long multiplication if you're not sure. I'll just show you one way of multiplying numbers the long way. So 5 times the 7 beneath is 35. Write down the 5, put down 3. 7 times 1 finally is 7, plus the carried 3 gives us 10. So it's 105. We've got 105. Now this question gives us a bit of a clue, which is we're essentially told here that we want our fraction to end up in terms of quarters. At the minute we've got twelfths. So what we could do here is to go from 12 down to 4, we could divide both top and bottom by 3. 12 divided by 3 will give us the 4 we need. If we do that to the bottom, we have to do the same to the top. So 105 divided by 3. I'll show you how to do it just in case. Can 3 fit into 1? Obviously, no it can't. So that 1 is still left over, that 1 is a remainder. So 0 is now 10, which is obviously 10. 3 does fit into 10 3 times. 3 times 3 is 9. 9 is still 1 away from 10, so again our remainder is 1. And 3 into 15 goes 5 exactly. Because it goes exactly, there's now no remainder. So 105 divided by 3 is 35. So 105 over 12 is the same as 35 over 4 by dividing both top and bottom by 3. Now, to get it into this form, we just simply see how many 4s fit into 35. Well, 4 goes into 35 8 times. 8 times 4 is 32, so we've got 3 left. The 3 left over is just the numerator above the 4. So 35 quarters is the same as 8 wholes plus an extra 3 quarters. So we've just shown that this here equals this, equals that, equals the other, equals this. So best way of doing it is just to actually perform the calculation like I've done, and that'll be sufficient for getting your mark. Let's now have a look at number 3, question 3. Question 3, we've got 4 graphs. We need to match each of these graphs to the correct equation. So I think probably the most obvious one is the graph of y equals x squared. This is a parabola, a happy parabola, which is essentially a U shape. So this one will link to this one here. So this one is graph D. Now, these ones here look almost the same, minus x cubed and also an x cubed. The graph of x cubed will look like a snake. It goes up, flattens, then goes up again. Minus x cubed is the same idea, but rather than snaking upwards, snakes downwards, like so. That's the graph of minus x cubed. This one here, snaking upwards, is a graph of positive x cubed. So the positive one I'll do first. This one is like graph C, and therefore graph D is y equals minus x cubed. Because this one and this one look pretty much the same, I'll be guessing that one of these is B, the other is C, okay, because these two look so familiar. But that's how you know. An x cubed graph will snake upwards with a little kink in the middle, and minus x cubed one will curve downwards in much the same way. Finally, the final one is what's known as a reciprocal graph, a graph of 1 over x, goes really, really high up and never quite touches the y-axis, and likewise goes really close to the x-axis but never quite touches. That's this graph here. Therefore, the final one to match is A. So B, C, D, and A. Question 4. Got 4 different triangles here. 2 of these triangles are congruent. Congruent is just a fancy word for meaning identical shape, identical size. Write down the letters of these two triangles. We need to now remember the tests of triangle congruency. Before we do that though, we can add on these missing bits of information for these 2 triangles. If that's 55 and that's 45, we can add on here that one must be 80. Remember, angles in a triangle add up to 180. In the same way, if triangle D has an 80 degree and 45 degree angle, that comes to 125. Therefore, this bit here is we're missing 55 degrees. These 2 in the middle, B and C, we only know one angle, so we can't work out anything extra for these middle 2. It's like I'm saying, the tests of triangle congruency, there's 4. So 2 triangles are congruent if all the sides are exactly the same, side, 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 or if 2 sides are the same and the angle in between those 2 sides they share. Also, you could have angle, side, angle, where you have a side trapped in between 2 angles. If they're the same for each triangle, those triangles must be identical. And finally, if both triangles are right-angled, with the same hypotenuse and another side that's the same, then by Pythagoras essentially, they must also be congruent, must be identical. So let's have a look at angle, side, angle. So if I highlight one of the angles in A, you can see here they've both got a 55 degree angle. The other angle, which is common to them, is this 45 degree angle as well. On its own, that's not enough to prove these 2 triangles are congruent. However, the side, which goes in the middle of them, if that's the same, that proves these 2 triangles must be identical. The side in between these 2 angles is 10 centimeters here, and the side in between these 2 is also 10 centimeters. So because of that, because they also share the same length side in between the 2 same angles, these 2 triangles, A and D, must therefore be congruent. So the answer is just simply triangle A and triangle D. Question 5. Sean is paying £10 for 24 chocolate bars. He sells all 24 bars for 50p each. We have to work out Sean's profit. Well, there is a formula for percentage change generally, which we can adapt. The formula, which is in its general form, is this. Percentage change is the change divided by the original amount multiplied by 100. Because we want percentage profit, this change becomes a profit. So the change at the top of the fraction becomes a profit. Original means what happened first. Well, at first, he bought them. So the original means his buying price times 100. So this is a formula we're going to be working with. So to find profit, profit is just a difference in between the money he makes versus the money he spent in the first place to make that money. So obviously he spent £10, but if he sells all 24 of these chocolate bars for 50p each, the money he makes is going to be 24 times by 50p. I'm hoping you'll think it's obvious that two 50p's make a pound, so 24 50p's would be £12. So therefore, his profit is this money he's made, which is £12, subtract the money he spent in the first place, which is this £10 to buy them. So £12, take away £10, gives us a profit of £2. So we're not done yet, but we're on the right lines. We now need to put these values into this formula. So therefore, his percentage profit is the actual profit he's made, which is £2, divided by his initial costs. Well, initially it cost him £10 to buy the chocolate bars, multiply by 100 to change it into a percentage. So what I'd suggest we do is simplify this fraction down. So 2 over 10 is the same as 1 over 5. And we times that by 100. 1/5 times 100 is the same as 1/5 of 100. So all we need to do now is to find out how many 5s go into 100. We do 100 divided by 5, which gives us 20%. The profit he makes is 20%. Another way you could have done it, instead of thinking of a percentage profit, you could have thought about what his fractional profit is. As a fraction, his profit is just simply this 2/10, which is 1/5. What's 1/5 as a percentage? 1/5 of 100, 20%. Question 6, we've got some angles in triangles. So let's talk this through and unpick it step by step. So we want to work out the size of angle EAB. So is it the angle at E, the angle at A, or the angle at B? It's always the middle letter you go for. So it's the angle at A as you move from E to A to B. So we're trying to find this angle here at the top. So what can we spot about this question? Well, I've just drawn in here a T shape. So I think of this as an upside down F, and we need to know that an F angle, the fancy word for these are corresponding angles. If that's 63, this one here will be 63 degrees as well. So that's the first thing we can note. We need to say as well, because the examiner wants us to give reasons, we say this angle here, which is the angle at E, angle AEB, this one, is the same as angle ADC, which is this one. And the reason, corresponding angles are equal, because there's a T angle or an F angle, however you want to see it. This one and that one are both corresponding angles. The next thing we can think about, because we're trying to find this angle in this triangle, if we can find this one, we're good to go. So this angle here, 148, is on a straight line. So if I put this blue line here, and imagine angles on the same side of this straight line. I've got 148 here. Angles on a straight line, you need to know add up to 180. So if that's 148, this one here will be 180 minus 148, which is 32. Like so. So again, we need to say to the examiner to prove to them, so you get the marks, how you know to do that. So we could say something like angle ABE is 180, take 148, which is 32 degrees, and give, for reason, angles meeting together on a straight line add up to 180 degrees. Now we can just zone in on this top bit on the triangle. Angles in a triangle add up to 180, so we can use that to work out the answer. Angle EAB will be 180 minus that one, which gives 85 degrees, and again tell the examiner what you did and what you knew to do that. The reason again here, angles in a triangle add to 180 degrees. Question 7, we've got a table of information about heights in centimetre of a group of Year 9 girls. So we've only got least and greatest and the median, not much to go off. And then we've got a stem and leaf for the Year 9 boys. We have to compare the distribution of the heights of the girls with the distribution of heights of the boys. From here, we can only work out the range and we know the median. So let's compare the range and the medians. That's what we need to do for this one. So for the girls, the range is the difference between the biggest and the smallest. So looking at these two here, the range is 170 take 150, which is 20 centimetres. And obviously the median is 165 because it says. For the boys, the least is this value here, which means 158 centimetres. Greatest, the maximum, is 182, which is 182. So therefore for the boys, the range is 182 minus 158, which if you take your time with, you should find that that's 24 centimetres. The median for the boys, we need to find the middle value. So what I'm going to suggest we do is we work towards the middle from each end. So it's not going to be the smallest ones. That's the smallest, second smallest, third smallest. Nor is it going to be the biggest ones. Biggest, second biggest, third biggest. So keep working in from end to end. Cross one off, 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 and finally cross this one, cross that one. The only thing we've got left is this 168. So therefore, the median is 168 centimetres for the boys. We can now compare these two. So compare the medians in context. Don't just say median for boys is bigger. Try and say what that means. So the first thing to say is because the median for boys is bigger, 168 is bigger than 165, we can say something along the lines of typically, on average, the boys tended to be taller than the girls. So what we can say here to start off with is something like this. Median height for the girls is lower than the median height for the boys, 165 centimetres versus 168. So Year 9 girls tend to be shorter than the Year 9 boys. Okay, I'll put the information back up as well in case you missed it from the other slide. So here it is again, just so you can see it all. So the median height for the girls is lower than the median height for the boys. So Year 9 girls tend to be shorter than Year 9 boys, or you could say Year 9 boys tend to be taller than Year 9 girls, whichever way around you want to do it. And the other point about the ranges, range measures consistency. The smaller the range, the more consistent the heights are. So because the range for boys is bigger than the range for the girls, we could say that the heights of the Year 9 boys are more varied or less consistent than the heights of the Year 9 girls. So you could say something like this, for example. The range for girls is lower than the range for boys, because 20 is less than 24, so the girls' heights are more consistent than the boys' heights. Something along those lines would get you the other mark. Question 8, we've got a diagram showing a prism placed on a horizontal floor. So let's think about this step by step. First of all, pressure is force over area. I think it's best here to do this as a magic triangle. You just simply cover up what you want to know. So what we're trying to work out here, ultimately in this question, is the force exerted. So if we want to work out the force, we cover up the force of our hands and see what's left. So the force means we cover up F here. We've got P and A left next to each other, which means P multiplied by A. It's a prism, and the prism has a particular formula for the volume. The volume of a prism is the area of its end times by the length. So the area of the end bit, we don't know, but the end bit just means the cross-section, which is this hexagon shape here, like so. The length, because it's stood up, is the height, so the length essentially is 3 meters. So now we can put these numbers into the formula. We know the volume, it's 18. So therefore we can say that 18 equals the area of the end, which I don't know, times by 3. So what number times by 3 gives us 18? Obviously it's got to be 6. So therefore the area equals 6. Therefore the pressure which the force which has been exerted, which is a pressure times by the area, well, the pressure is 75 newtons per square meter, and the area we've just worked out, which is 6. So take your time and work out what 75 times by 6 is. You should find that gives you 450 newtons. So the force exerted is 450 newtons. And that's all we have to do for that one. Number 9, we have to write these numbers in order of size, starting with the smallest. So these are a mixture. That one's in standard form. That one's not in standard form because it's a number bigger than 10 times 10 to a certain power. So it looks like it's in standard form but isn't quite. That again is times 10 to a certain power. That's looking like a normal number. You could either change them all into standard form, or what I'm going to suggest you do here is you change them all into just normal, honest-to-God numbers. So first of all, let's change this first one into a normal number. So we're timesing this number by 10 to a positive power. So the positive power of 10, we're multiplying it by, tells us how many digits the decimal is going to jump across to the right. So because this is 10 to the 5, that decimal is going to jump 5 digits to the right, like so. So we write down the number as it looks without the decimal. So 6, 7, 2. And then we think where the decimal is currently, which is here, and then it's going to move 5 numbers to the right. So jump 1, jump 2, 3, 4, 5. So it's going to end up here. So it jumps over the 7, jumps over the 2, jumps over nothing, over nothing, over nothing, and nothing mathematically is a 0. So that one here is simply 672,000 point nothing, which is just 672,000. So it's pretty safe to say that number's not going to be our smallest. Let's have a look and think about the next one. So this one here, 67.2 times 10 to the 4. I'll do it in a different colour, in fact. So for this one, what we're going to have is the same idea as before, but here, because it's times 10 to the power minus 4, this dot, rather than moving to the right, is going to move to the left 4 places. So we can write 672 as the number looks, put the dot where it is currently, it's in between the 7 and the 2 here, then move it back 4 places to the left. So 1 place, 2 place, 3, 4. So the decimal is going to end up here. There's nothing before the decimal, nothing in maths is a 0. It jumped over nothing here, nothing in maths is a 0. Jumped over nothing there, which again is a 0. So this one is 0.00672. And the last one we're going to do is this one, because this one's already as a normal number. So looking onto this one doesn't have a decimal on it, so I'm going to add a decimal at the end. So it's 672. Imagine it's 672 pounds, for example. 672 pounds could be written like this. That's the same value as that. Of course, I don't need a pound sign, so I'll just take this away. But just to make the point that 672.00 is the same as 672. So now I've got a decimal there to work with. I use the same idea as before. I'm timesing it by 10 to a positive power, so this decimal is going to move 4 places to the right because that 4 is a positive number. So we're going to move 1, 2, 3, 4 to the right, and it'll land there. So the dot jumps over nothing, nothing, and nothing after the dot 2. So that's going to be 672.0000, which is actually 6,720,000. So quite a big number. And the last one we can leave as it is. So let's think what the smallest is. So small numbers are going to be 0 point something. This is 0.00, but this is 0.000. That's got 3 zeros after the decimal. That's only got 2. So this one here is actually our smallest. So we're going to put this first. Now, this number here, this is thousands and that's millions. They're going to be the 2 biggest. So it's fairly obvious to see that the second smallest is going to be this one. The next one is going to be 672,000, which is 6.72 times 10 to the 5. Therefore, the biggest is this one. Now, it says write these numbers in order of size, so that we need to write the numbers the question gave us. We don't do our versions of the numbers. We need to write these numbers here that have put the circled numbers below. So the smallest number, number 1, is 0.000672. So I'm just going to underline this final answer in red. The smallest, like I say, 0.0000672. The next one is 67.2 times 10 to the minus 4. Third, 6.72 times 10 to the 5. And the biggest, 672 times 10 to the 4. So that's the numbers written in the correct order. Question 10. We're given that the fraction a to b is the same as 2/5, and the fraction of b over c is the same as 3/4. So we're given fractions here, but then actually we want our final answer in terms of a ratio. So the first thing I'd suggest to do would be to change these change these fractions and rewrite them as ratios. Because we've got a ratio here in terms of what we want our answer to be. So rewrite the question as ratios. So this one here, a over b is the same as 2 over 5. I can rewrite this as the ratio of a to b is the same as the ratio of 2 to 5. This one here, I can rewrite as a ratio of b to c being the same as a ratio of 3 to 4. Now I've got these two as ratios, I can now compare these, and the best way I think to compare ratios is by using a table of values. Now people use different methods. For example, bar models are very common. If that works for you, great. I'm not knocking a bar model, they do work very well, but for the sake of this video not being 10 hours long, I'm just going to show you how to do this using a table of values. So here's the table. So the first one, a to b is 2 to 5, we can add this in. And the second one, b to c, is 3 to 4. Now I have to keep them on separate lines because you can see the b numbers don't match. 5 isn't the same as 3, so I've got to keep these separate. But we can change that. How could I get 5 and 3 to be the same number? What number could I multiply each by? Well, the lowest common multiple of 5 and 3 is 15. So I can multiply this top line by 3, then I'll get b as 15, and I can multiply this one by 5, which again will give me a b number here of 15 too. So if I times this red one by 3, 2 times 3 is 6, 5 times 3 is 15, then this one here in green, if I multiply both parts by 5, that'll give me a ratio of 15 to 20. Now, because the b numbers match, I can now merge this into one line. Because 15 is the same as 15, I can just put this here like so, and then you can see the ratio of a to b to c is just simply 6 to 15 to 20. Question 11. Find the value of the fourth root of 81 times 10 to the 8. Well, we need to remember that you can actually split surds up. So to find the fourth root of 81 times 10 to the 8, we can say this is the same as the fourth root of 81 times by the fourth root of 10 to the 8. Now, the fourth root means just what number times by itself 4 times in a row would give you this. It's a non-calculator paper, so don't be thinking it's going to be an awkward, horrible decimal. Just be thinking, is it going to be 1? No. 1 times 1 times 1 times 1 still stays as 1. Is it 2? No, because 2 times 2 is 4, times 2 again is 8, times 2 is 16. However, 3 times 3 is 9, times 3 again is 27, times 3 again is 81. So this here is 3. And then what number times by itself 4 times gives us 10 to the 8? This is a bit more to think about, but what I'd suggest you do is just think of it in terms of powers of 10. So 8 divided by 4 is 2. It's going to be 10 squared. Remember, what's 10 squared times 10 squared times 10 squared times 10 squared? When you're multiplying with indices and the base numbers are the same, we just add these top numbers together. So 2 plus 2 plus 2 plus 2 does give us 8, which is exactly what it should do. So the fourth root of 10 to the 8 is just 10 squared. But we need to find the value, not just leave it like this. 10 squared is 100, so this is the same as 3 times 100, and 3 times 100 is, of course, 300. Part B, we're asked to find the value of 64 to the power negative a half. So this is a fractional index, so I always like to think of it like this. Flower power. A flower grows from the roots come first, the flower comes second. So root the number first, the root is the bottom number, and then do the power, which is the top number, the flower power comes second. So first of all, we do the bottom number first. The bottom numbers are 2, that's the root, so what number times itself twice gives us 64? Essentially, we're trying to find the square root of 64. So we do that first, and then we deal with the top minus 1 after. Well, the number which times by itself to give 64 is 8, so the square root of 64 is 8. So I've got 8 to the power minus 1. You should hopefully know that if you've got something to the power minus 1, this just means you do the reciprocal. You turn this number on its head. So as an optional extra step, I'm going to rewrite 8 as 8 over 1. If you're wondering why is he doing that, you don't need to do that. I'm just going to make the point clearer that anything to the minus power is you just flip the fraction. So 8 over 1 becomes 1 over 8. And then this minus power becomes a positive. So the power minus 1 here becomes positive 1, but anything to the power 1 is just itself. So the answer is just simply 1/8. 2 to the minus 1 is 1 over 2. 8 to the minus 1 is 1 over 8. So it works in the same way. The last one, we need to write this horrible looking fraction as a power of 3. So the clue is actually in the question. We need to have everything as a power of 3. The top of it is already a power of 3. It's 3 to the power n. The bottom, though, is as a power of 9. So 9, this is as a power of 9. I want it as a power of 3. So I can rewrite 9 in terms of 3. So 9 is obviously 3 squared. So I'm just going to replace 9 with what 9 is in terms of powers of 3. And that is to the power n minus 1. So next up, At the bottom, we've got two powers next to each other, power of a power. So how do we do these? Well, what we do is we multiply this power by the one it's floating next to. So we do 2 times n, which is 2n, and then 2 times minus 1, which is minus 2. So we've got here a power of 3 divided by another power of 3. At this stage, we need to remember how we divide with indices. If the base is the same and we're dividing, we do the first power, which is n, take away the power of the thing we're dividing by. So we minus off the power 2n minus 2. I'm going to put it in brackets because we're minusing off that whole thing. Just be very careful of these negatives. So, because we're minusing minus 2, if you minus a minus, it makes a plus. So minus minus 2 gives us plus 2. And 1n, take away 2 n's, gives us minus n overall. So the overall power of 3 we have is 3 to the power of 2 minus n. Question 12 gives us a table of information about weekly wages of 80 people. For part A, we have to complete the cumulative frequency table. So cumulative means a running total, so we add up as we go down the rows. So the first cumulative frequency, the first row, is going to be the same as the first row of the standard table. So we're just going to fill in first of all 5. The next one is going to be 5 plus the next 10, which will be 15. Next one, 15 plus 20 is 35, plus the next 20 is 55, 55 plus 15 is 70, and then 70 plus 10 gives us 80. So we're going to use this table from part A to help us with part B. Part B, of course, is using the grid opposite on your exam paper to draw a cumulative frequency graph for this table we've just done here. So if we just say bye-bye to the table for a moment, we'll put it back in a moment, but if we just say hello to the graph, which is here, and of course we need that table of values to plot from. Now, with these we always plot from the endpoints. So rather than plotting at 200 then up to 5, we always plot from these numbers here at the end. So we're going to go 250 along and 5 up for the first one. The next one, along 300 and up to 15, which is going to be here. Then 350 and up to 35, which will be here, like so. 400 and along 55 up, which is going to be up here. For the next one, along to 450, up to 70. And finally 580. So there's the points, and you need to draw, if you possibly can, a smooth curve through these points, something that looks a bit like this. So that's a cumulative frequency curve I've done in blue. We're then going to use that blue curve to answer the next question. So 1 says 60% of this group of people have a weekly wage of £360 or less. Is 1 correct? You must show how you get your answer. So there's a couple of different ways of doing this. I'm just going to show you one particular way. What I'm going to suggest is we have a look at how many people do earn up to £360. So I'm going to read off at 360 up here until we get to the line. So reading up to the curve, we get to that point. Once we get to that point, we can read across and find out what numbered person we have. And this here, as you can see, gives us 40 people. So that means that 40 people and fewer, up to 40 people, earn £360 or less. So 40 people earn this amount or less, is what this tells us from the curve. So because 40 people earn £360 or less, that's not the same as what this is saying, because 60% of 80 people would have been 48 people, not 40. So if this read off and got to 48, which would be 60% of 80, he'd be correct. But because 40 out of 80 is 50% of the people, not 60, 1 is wrong. So something like this and some explanation like this would get you the full marks for part C of question 12. So in other words, 1 is incorrect, unfortunately for him. Question 13, we've got 3 different liquids, A and B, they're then made together, mixed to make the third one C. So liquid A, we're given the density and mass, but not the volume. Liquid B, we're given the density and volume, but not the mass. We need to work out the density of liquid C. This is a density, mass, volume question with multiple parts. So we need to remember how density, mass, and volume relate. Density equals mass over volume, and we can use this magic triangle to help us if needed. Density equals m over v. And to work out what you want, you just cover up what you want to work out. What's left tells you what to do. So here's a little hand to make it handier. So let's think about liquid A. So liquid A, we're told the density and the mass, but we're not told the volume. So what we could do here is work out the volume of liquid A. So what we're going to do is take the hand, cover up volume, and see what's left. We've got mass over density, therefore the volume of A must be the mass of liquid A divided by the density of liquid A. So the mass of liquid A is 1400 kilograms. The density is 70, so we need to do 1400 divided by 70. Both numbers end in 0, so we can cancel those off. So it's the same as 140 divided by 7. Well, 14 divided by 7 is 2, therefore 140 divided by 7 is 20. So the volume of A is 20 cubic meters. Now considering liquid B. So for liquid B, we're told the density and the volume, but we're not told the mass. So for liquid B, we could work out the mass of it. So how do we work out the mass? Well, we cover up the mass and see what's left. Cover up mass, D and V are left, and these are right next to each other. Two things next to each other in maths means you times them together. So the mass of B will be the density of B multiplied by the volume of B. The density of liquid B is 280, whereas the volume of it is 30. So what we can do here is 280 times 3. 28 times by 3 is 84. Add on these two zeros, we get 0, 0 kilograms. Finally, to work out the density of liquid C, if we want to work out the density of C, we can just cover up D for density, and it's going to be the mass divided by the volume. So density of C is mass of C divided by the volume of C. But because C is the mixture of A and B together, the mass of C is just the mass of A plus the mass of B, and the volume of C will be the combined volume of A plus the volume of B. So the total mass we can now work out. So the mass of A is 1400, so we can just obviously colour code that if we want to. And the mass of B, well, we worked that out here. So the mass of B is 8,400. So we add those two together. So 1,400 plus 8,400. Probably easier to just do 14 plus 84, which is 98. Then you can add in the zeros afterwards. So 9,800 kilograms in total. And we can now divide that by the total volume, which is the volume of A added to the volume of B. The volume of A we worked out here was 20. And the volume of B, we were told that had a volume of 30 meters cubed. So we're going to add together 20 plus 30, which is 50. So we're now dividing 9,800 by 50. Both whole numbers ending in zeros, so we can cancel off the end zeros and then do 980 divided by 5. It's non-calculator paper, so we need to rely on the old bus stop. Can 5 fit into 9? Well, yes it can. It fits once. 1 times 5 is 5, so there's still 4 left over, so the remainder is 4. Next, 5's into 48. We can fit 9 of them. 5 times 9 is 45. And so we've got 3 left over, because 45 is still 3 away from 48. Finally, 5s into 30 goes 6. So the density, therefore, is 196 kilograms per cubic meter. And that's all we need to do for that one. So we can now move on and start thinking about question 14. Question 14 is probability related. Now this one here, we can do it using a tree diagram or without. It's one of those where you've got a couple of different approaches. I think probably the easiest is doing it as a tree diagram. So let's just pick out this information here. So we've got here that Sally is playing 2 games against Martin. She could either win, draw, or lose. But look at the actual question. The actual question saying work out the probability that she will win exactly one of the 2 games against Martin. So we're only concerned if she wins or not. So we can think of it as either she wins or that she does not win. So that's going to be what I'd suggest we do first of all. It's only concerned with her winning, so think of it as either she wins or that she does not win. So we're told here the chance Sally will win against Martin is 0.3, the chance she will draw is 0.1, therefore I can just add in this extra third line. If she doesn't win or draw, which has a total probability of 0.4, the other 0.6 must be the probability that she loses against Martin. Remember, the sum of all probabilities needs to add up to 1. 1 minus 0.3 minus 0.1 gives us this 0.6 chance that she'd lose. She's going to play Martin twice. She's playing 2 games. So for the first game, she could either win, which is a 0.3 chance, or she could not win, which is a 0.7 chance. So the chance for winning is 0.3. Combine the 0.1 and the 0.6. We get here that the chance for not winning, therefore, is 0.7. So now we can start to construct the tree diagram. So here's the first branch for game 1. So the chance for winning is 0.3, which we can add on. And the chance for not winning is 0.7, so we can add this on as well. We now need an extra branch for game 2. And likewise, for game 2, we need to add on the probability that she wins and does not win. Another 0.3 and 0.7 for each branch. So we need to work out the chance that she wins exactly one of the 2 games. So there's 2 ways this could happen. She could either win the first one and then not win. So she could win first and then not win for the second game. So doing that would be the route I'm going to show you here. So she could win there and then go and not win for the second game. Or, so if it's or, we can add, it's also a probability that she could not win the first game and then, so a big and, if you're wondering why I'm doing the and, massive and underlined, I'll explain what I mean by and in a moment. So she could not win first and then she could win on the second game. So doing this route, which I'll highlight in a green, actually no I won't, because then this green will not look very clear, will it? So this option here is if she did not win the first one and then ended up winning the second. So and with probability relates to multiplication. So what we do here, we take the probability that she wins and we multiply that by the probability that she does not win. So this is going to equal the chance of her winning the first one, which is 0.3, and then I multiply that by the chance of her not winning, which is 0.7. I'm going to add the probability on that she wins first, which is a 0.7 chance, and then, so then we multiply that by the chance of her winning the second, which is 0.3. So 0.7 times 0.3 will be the same as 0.3 times 0.7. The same numbers, the order's switched, but when we switch the order in terms of when we're multiplying numbers, it doesn't affect the outcome. 2 times 4 is the same as 4 times 2. So really, we just need to do one calculation and double it. So ignoring the decimals, what's 3 times 7? Well, 3 times 7 is 21. However, this calculation here has 2 decimal places in total. There's 1 digit after the decimal here, and 1 after the decimal here too. So in our answer, we need 2 numbers after the decimal also. So here, that needs to be 0.21. If that's 0.21, this will also be 0.21, which gives us a total probability of her winning exactly 1 game of 0.42. Let's have a look now at question 15. Question 15, we've got a straight line, L1, which has equation y equals 3x minus 4. The straight line L2 is perpendicular to L1 and passes through the point 9,5. Find an equation of L2. You don't have to, but my suggestion here would be to draw out this on a diagram. So L1 is y equals 3x minus 4. So let's imagine this on a coordinate grid. So here's an x-axis and y-axis. 3x minus 4 would be a straight line going upwards, and it would cross the y-axis at minus 4. But I'll come to that in a moment. So here's L1. Now, this is in the form y equals mx plus c. The number in front of the x, when it's written in this form, tells us the gradient, in other words, the steepness. So this means for every 1 we go along, L1 goes 3 units up, like so. The number at the end is minus 4. This minus 4 tells us where it crosses the y-axis, so it crosses the y-axis down at minus 4. We now need to work out the equation of this L2. We're told L2 is perpendicular to L1, so it will cross here at a 90-degree angle. So it's going to have a gradient which will be negative. So let's just get L2 put on. It'll be something like this. Don't worry about sketching it accurately. But what is important is it passes through this point 9,5. So 9,5, if I just sketch on where that might be, don't worry about doing it too accurately. I'm going to put 9 and 5 about here. And just to drive home the point that these 2 lines are perpendicular, which means they meet at right angles, here's a little right angle for us. Now what you need to remember is how to work out the gradient if one line is perpendicular to another. Any line perpendicular to L1 will have a gradient which is the negative reciprocal of the gradient of L1. So the gradient of L2 will be minus 1 divided by the gradient of L1. So the gradient of L2 is minus 1/3. So now the equation of L2 will be of the form y equals mx plus c. So y equals mx plus c, where m is the gradient. I know the gradient now is minus 1/3 because it's a negative reciprocal of 3. So it's minus 1/3 of an x plus c, where c is the y-axis intercept for L2. So how do we find c? Well, what we can do here is we can substitute in a point we know. We know L2 goes through when x is 9 and y is 5, so we can substitute these points in. So when y is 5, sorry, when y is, dear me, sorry, when x is 9, making a dog's dinner of this, sorry, when x is 9, y is 5. So we sub these points in. So when y is 5, that gives us 5 equals minus 1/3 of what x is. And so if x is 9, that means minus 1/3 times 9 plus c. So ignore the minus for a second. 1/3 times 9 means 1/3 of 9. 1/3 of 9 is 3, so minus 1/3 of 9 is minus 3. So 5 equals minus 3 plus c. We can now work out what c is by getting rid of this minus 3. The opposite of minus 3 is adding 3. So if we add 3 to both sides, that'll give us what c is on its own, which is what we want. So therefore, 5 plus 3 is 8, and that is equal to c. Therefore, we can work out what the equation of L2 is. We know its gradient is minus 1/3. We know its y-intercept now is 8. So L2 is y equals minus a third x plus 8. And we've now cracked it. Question 16. Shirley wants to find an estimate of the number of bees in her hive. So on Monday she catches 90 bees and she puts a mark on each bee and returns them to her hive. So let's just think about this first of all. So she catches 90 bees. So here are 90 bees. Count them if you want to. I've actually done 90. So they're black and white boring bees. She's going to mark them, and when she marks them, they're going to be brought to life. So the marked bees are going to look like normal bees. So imagine these 90 going from black and white into lovely technicolor, like so. So she's marked them so they look like normal bees. They're now going to return to the hive, like so. So they're going to vanish and disappear and mingle and mix in thoroughly with all the other bees that are not marked. So bye-bye marked bees. Then what happens is now the bees that have been marked are thoroughly mixed up and randomized with the other bees. On Tuesday, she catches 120 of the bees. So some are going to be marked, some aren't. So of the 120 she catches, she finds out that 20 of these have been marked. So she catches them in a net, or I don't know, I'm not a beekeeper. So here they are. So 120 and 20 of which are marked. So 6, 12, 18, 19, 20 coloured in bees out of 120 in total. So one way we can consider this now is to think of this as a fraction. So of the 120 she's caught, 20 have been marked. 20 out of 120 are marked. Write that as a fraction and simplify. That tells us that 1/6 of these bees are marked. So the best estimate is, assuming these bees have thoroughly been mixed in, then she marked 1/6 of them. So how many did she mark? Well, she marked 90 bees. So those 90 bees she marked, the best estimate is, that must have been 1/6 of the total bees. So if 90 is 1/6 of the total of them, how many sixths makes the whole lot? Well, 6 sixths makes a whole. So if we multiply both sides of this relationship by 6, we'll see that our estimate for the total number of bees she's got must be, in total, 540 bees altogether. Now, as well as that, there's another way of thinking about it which you might prefer. If you look here, if 120 were caught in total and 20 were marked, you can see here from this diagram, for every 5 that aren't marked, 1 was marked. So you can think of this question, if you prefer, as a ratio. So every 5 unmarked to 1 marked is a total of 6, but of course we knew that 90 were marked in total. So to go from 1 to 90, we'd have to multiply both bits of this ratio by 90. So 1 times 90 is 90, 5 times 90 is 450, so the total number of bees altogether is the 450 that were unmarked plus the 90 that she did mark, gives us again a total of 540 bees as our estimate. Now there's part B to this question, part B, get it? Bees, part B, terrible. Anyway, for part B, Shirley assumes that none of the marks had rubbed off between Monday and Tuesday. If Shirley's assumption is wrong, explain what effect this would have on your answer to part B. So, assuming that she's wrong, so let's assume that some did rub off and that actually here some bees had been marked but they'd rubbed off. So let's just imagine maybe doubling up how many are actually marked. So I'm just adding in here some more bees that were marked, and imagine these marks I'm doing now in this yellow highlighter, imagine these rubbed off to leave only the ones I showed to you that over 20. So it might be that actually 40 out of 120 were marked, but then just half of them rubbed off. So let's just make up a number and increase the number she sees. So 40 out of 120, that would have been 1/3, just for example. So then it would have been 1/3 is 90 bees. So 90 bees, if it were 40, I don't know, but just if it were more bees that were marked, 90 bees would have been 1/3 of them. Times both sides by 3, that would have been that the total number of bees is 270. So actually, if Shirley's assumption is wrong, then part A would be an overestimate, because if more B's were marked, as you can see here, imagining that 40 were marked rather than the 20 she thinks, that would have actually halved the actual real total. So if she's wrong, this 540 would be an overestimate. So the wording just needs to be something along these lines. If some marks had fallen off, she will have overestimated the number of bees in the hive. Simple as that. So I'm just trying to explain why the wording and the explanation is how it is. Essentially, it would have been an overestimate from part A. Question 17, we have to make F the subject of this formula. So it's quite a tricky rearrangement. So far, D is the subject of this one. We need to make it F. So we need to get F on its own, isolate it, so it then becomes F equals whatever it equals. So the first decision we could make would be to expand the brackets. So that's what I'm going to do here. It's going to expand the brackets on the top. That'll then give me D equals 3 times 1, which is 3. 3 times minus F is minus 3F, all over F minus 4. Now, if F is a subject, we can't have F in the denominator of the fraction, so we need to multiply through by this whole denominator. Not just the F, not just minus 4, but times through the whole thing by the whole of F minus 4. So times that side by F minus 4, and therefore multiply the D by F minus 4. And if we do that, what we'll get over here is D times F minus 4 equals 3 minus 3F. Again though, we've got F's on both sides of the equation, and it's one of these F's is tied up in a bracket. So what we need to do first of all, I'd suggest, would be to expand on this side. So if we expand these brackets, what we'll get is D times F, which is DF, D times minus 4, which gives us minus 4D, equals 3 minus 3F. So we're getting there a bit closer. What we need to do next though is to get all the F's onto the same side of the equation. So what we could do to undo this subtracting 3F, the opposite of that, would be to add 3F onto that side. That would make the minus 3F disappear. But if we add 3F over here, to keep it nice and balanced, we do exactly the same operation on the left. Then what we'd have would be DF plus 3F, still with this minus 4D, equals 3. So we want F's on one side, everything else on the other. So we can get rid of this minus 4D by adding 4D. If we do that to the left, we need to do the same operation to the right. So the left will simply become DF plus 3F, and this side will become 3 plus 4D. We can now factorise out the F from the left-hand side. Leave the right-hand side alone. Then we'll have F brackets D plus 3 equals 3 plus 4D. And the final step, to get F on its own, will be to divide both sides through by this bracket D plus 3. So do this operation to both sides, and then we'll have D on the right-hand side, F on its own in the form F equals. In other words, we'll have F as a subject, which is what we wanted all along. So then we'll have F equals 3 plus 4D, all divided by D plus 3. And that is, thankfully, our final answer to that one. Question 18, we're told that x is proportional to the square root of y, where y is greater than 0. We're then told that y is increased by 44%. So work out the percentage increase in x. So first of all, if x is proportional to y, that means x fishy square root of y. This symbol obviously just means is proportional to. The proportionality symbol can be replaced with an equals sign. If it's direct proportion, it means that x is equal to some constant multiplied by the square root of y. So it's k times the square root of y. We're told here, though, that y is increased by 44%. So what this means here is that y must have been multiplied by some number to increase it by 44%. This is where decimal multiplier knowledge can come in handy. So how do you increase something by 44%? Well, to increase by 44% means the initial 100% of itself plus an extra 44%, which is 144%, which as a decimal multiplier is 1.44. So in other words, y must have been multiplied by 1.44. Now what we can think of is the original values of x and y compared to the new values. So let's think of the initial value of y. So originally y was just simply y. The new value of y, because it's been multiplied by 1.44, the new value of y is just 1.44 times the old value of y. It's been increased by the 44%, which is a decimal multiplier is 1.44. That will then cause a corresponding increase in x. So x used to be k times root y, whereas now, with this new increased y, x will now equal k times 1.44y. So now we need to think about this. 1.44. Well, we're square rooting something. So here, knowledge of square numbers would be useful. So let's just put this in a thought bubble. We should hopefully know that the square root of 144 is 12. Therefore, by just thinking of this as the same looking number with a decimal, we can hopefully work out what the square root of 1.44 would be. That would be 1.2. So the new y is k times the square root of 1.44y Now in terms of surds, it's the same as saying the square root of 1.44 times the square root of y. We can split the surd into two bits like so. However, we've just seen that the square root of 1.44 is 1.2, so I can take this and rewrite it as 1.2 at the front. So if this root 1.44 is the same as 1.2 multiplied by k times root y. And that was the original value of x. So the original x was k times root y, which is what we've got here. So the original value of x has been multiplied by 1.2. Now let's think about decimal multipliers. To increase by 44%, that's a decimal multiplier of 1.44. We've now increased the original x by this decimal multiplier. It's a decimal we've multiplied by. It's literally a decimal multiplier. What might help is if I put an extra invisible 0 after this 2. 1.2 is the same as 1.20. So increasing by 44% is 1.44. In the same way, if we're multiplying the original x by 1.20, we've therefore increased x by 20%. So therefore, percentage increase is 20%. Question 19, we've got some functions to work out, some composite functions and an inverse as well. So first of all, we need to find what g of 5 is. So g of x, whatever x may happen to be, is 3 lots of 2 lots of x plus 1. So if we have g of 5, we just replace the x with the 5. So g of 5 will be 3 lots, now not 2 times x, but 2 times 5, plus 1. The laws of BIDMAS still apply here. So again, we've got brackets, so we're going to work out the brackets first. Within the brackets, so we have a multiplication and an addition. What comes first in BIDMAS? Well, we need to multiply before we add. So we're going to do the 2 times 5 first. 2 times 5 gives us 10, then we'll add 1 after. So we still need to work out the brackets. We now can. 10 plus 1 is 11. So this becomes 3 times 11, which is 33. So g of 5 is 33. The next thing we need to do is to find g of f of 9. Now these ones we have to work from the outside in. So we start with f of 9 first of all. So we do g of f of 9. So f of 9 will be 12 divided by the square root of 9. Now the square root of 9 is obviously 3. This is g of 12 divided by 3. In other words, we're going to work out what g of 4 is. It then becomes very much like part A. So rather than g of 5, we're now going to work out g of 4. So it's now 3 lots of 2 times 4, because now it's not g of 5, it's g of 4, plus 1. And again, using the same idea of BIDMAS, we're going to do brackets first and the multiplication in those brackets first. 2 times 4 is 8. We'll add 1 next. 8 plus 1 is 9. So we've got 3 times 9, which of course is 27. Now we need to work out for part C, g minus 1 of 6. Now this is just notation, which means finding the inverse of the function g. So what we're going to do here is we're going to start with x, because x is typically the input into g. But what we're going to do here, my suggestion would be to expand the brackets to make g easier to see. So g of x, if we expanded these brackets, 3 times 2x is 6x, and 3 times 1 is 3. So we're going to think of g of x like this, because this version of g of x is just a bit easier to deal and picture with than this one. So x comes along. What's the first thing that happens to x? Well, x gets multiplied by 6. And times by 6, that gives us 6x. After it's been multiplied by 6, we add 3 to it. We then get 6x plus 3, and that is exactly what g of x actually is. To do the inverse function, we start at the end and input x and go the opposite way, going from right to left, doing the opposite steps each and every time. So now I'm going to pop x in here and go the opposite way, doing the opposite thing each time to do the inverse. Inverse is like the opposite, so we do the opposite things. So here, instead of adding 3, we're going to take away 3. This step above, we multiplied by 6. The opposite of multiplying by 6 is to divide by 6. So if we do that with x, what we'd be doing is having x, taking away 3, then dividing that all by 6. And that is therefore g minus 1 of x. So therefore, g minus 1 of x equals x minus 3 over 6. So now, if we want the specific value of g minus 1 for when we're inputting 6, we're just going to replace our x with 6. So therefore, using this formula, now for g minus 1 of 6 is going to be 6 minus 3 over 6. 6 take away 3 is 3. 3 divided by 6 is 1/2, or 0.5 if you really want to. Therefore, g minus 1 of 6 is a half, just as we've done there. So part A, 33, part B, 27, part C, we've got 1/2. Question 20. Show that this horrible, horrible thing can be written in the form a plus root 5 over b, where a and b are both integers. So let's be thinking how we can do this beastly question. Well, it might not seem it now, but this is actually a case of having to rationalise the denominator. So what we need to do at some point is to multiply both top and bottom by 5 root 5 minus 5. However, we need to focus on this root 180 and see what we can do with this root 180 on the numerator. What I'm getting at here is that we can simplify some surds if we have a surd, something inside the surd, which has a factor which is also a square number. So if I just zoom in on 180, it is actually the fact that 180 has square numbers as it factors of it. The biggest one is actually the square root of 36. So I can take the square root of 180 and rewrite 180 as a multiple of 5. The clue here, this is in terms of root 5, that's in terms of root 5. And because this number ends in a 0, we could also get this in terms of root 5 as well. So how many 5s go into 180? Well, how many 5s go into 1? 5's too big to fit into 1, so that 1 is a remainder. So 5's into 18, 5, 10, 15. We can fit 3, but 15 is still 3 away from 18, so the remainder there is 3. Finally, 5's into 30 goes 6 exactly. Therefore, root 180 can be split into root 36 and root 5. And like I said earlier, square root of 36 is, of course, this is a square number, so the square root of 36 becomes 6. So I can replace root 180 with 6 root 5. So therefore, this thing here becomes root 180, which can be about 6 root 5, minus 2 root 5, all over 5 root 5 minus 5. But 6 lots of root 5 take away 2 lots of root 5, it'd be 4 lots of root 5. In exactly the same way as 6x take 2x, it'd be 4x. So I've got 4 lots of root 5 here, and underneath I've got 5 root 5 minus 5. At this stage, I can now rationalise the denominator, which just means getting rid of any surds on the bottom. And I do that by multiplying top and bottom by pretty much the same thing as what's on the bottom, but with this symbol switched. So I switch the minus to the opposite of minus, which is plus, and I multiply both top and bottom by the same thing. So, expanding surds essentially. So how to do that? I've got a couple of templates which might help you. Like expanding brackets in algebra or expanding surds. I tend to prefer the box method personally. So, at the top, 4 root 5 times 5 root 5 plus 5. So we can do the top by looking at this grid. So 5 root 5 times 4 root 5. Do the normal numbers first. 5 times 4 is 20. The square root of 5 times the square root of 5 gives us just 5. So that becomes 20 times 5. This box here, 4 times 5 gives 20. So this gives us 20 root 5. So the top of this fraction here, that times that, gives us 20 times 5, which is 100, plus 20 lots of root 5. Whereas on the bottom of the fraction, I've got 5 root 5 minus 5, this here, times 5 root 5 plus 5, which I've got here. So the box is in any order. If I do the top left, just picking it at random, 5 times 5 gives 25. Then I've got root 5 times another root 5, which is 5. So that becomes 25 times 5, which is 125 if you're wondering. This bottom box, 5 root 5 times minus 5, well 5 times minus 5 is minus 25. So 5 root 5 times minus 5 gives us minus 25 root 5. At the top, 5 times 5 is 25, so 5 times 5 root 5 is 25 root 5. Finally at the bottom, 5 times minus 5, a positive times a negative makes it a negative overall. 5 times 5 is 25, but because we're doing a positive times a negative, that gives us minus 25. And as you can see here, positive 25 root 5 will cancel with minus 25 root 5. Those two knock each other out. So what we're going to have here is 25 times 5, which is 125, minus 25, which just gives us 100. Now we want the answer in this form, so we want it in two separate parts. So what I'm going to suggest we do is we split this fraction into 100 over 100, and then 20 root 5 over 100. So then we get 100 over 100, anything divided by itself gives us 1. And this here, 20 over 100, well, 20 over 100 is the same as 1/5. So this bit here becomes 1 root 5 over 20, but 1 root 5 we can just write root 5. So it's 1 plus root 5 all over 5. And that one is our final answer. Let's now have a look at the next question, which is number 21. At question 21, we encounter a fairly nasty vector problem. So we're told that DEF is a triangle, P is a midpoint of FD, and also that Q is a midpoint of DE. So P and Q are midway along each of their respective lines, from F to D, then from D to E. The vector going from F to D is labelled by vector A, and going from F to E is given as vector B. Use a vector method to prove that PQ is parallel to FE. Well, we need to know and remember that if two vectors are parallel, then one vector is a multiple of the other. So just write this down. You don't need to write this down to the examiner, this is just for me to remind you. So if two vectors are parallel, then one of those vectors can be written as a multiple of the other. So that's our target. We need to get that PQ is a multiple of FE or vice versa. So if two vectors are parallel, one vector can be written as a multiple of the other. So let's aim for that target. So first of all, let's think about PQ. We know that FE is just simply B. So from P to Q, well, we don't know how to get from P to Q directly. So what we could try to do is go from P to D, and then once we're at D, go from D to Q. So go PD, and then from D to Q. Now PD is half the distance of F to D. So from P to D, that's going to be half of what FD is. So I'm just going to rewrite what PD is in terms of FD. And then DQ, well, there's no vector we're given that goes from D to Q. So from D to Q, because Q is only halfway from D to E, I'm going to rewrite that DQ as being half of what it is from D to E. However, we don't know what D to E is either. So let's be thinking how you could go from D to E using vectors we know. I'm going to leave half FD as it is. Then to go from D to E, we could go from D to F, and it's good to get it in that form because we know a vector that goes from F to D. So to go from D to E, we could go from D to F, and then when we're at F, we can go along from F to E. Now at this stage, we can start filling in the vectors we know. So FD, well, from F to D, that's vector A. So half of FD is the same as saying it's half of vector A. So I can fill this in. And now we can think about this bit here. So plus half of D to F. So F to D is A. D to F is the same length, just going in the opposite direction. So that's going to be minus A, because it's going in the opposite way to where normal A is going. So they're going upwards from F to D, going along the same path, but downwards from D to F. Then from F to E, well, we're told what from F to E is. That's just simply vector B. So it's half of minus A plus B. We can now expand these brackets like we would any normal algebraic brackets. So we're going to have here a half A first of all. A half times minus A gives us minus half of an A, plus a half times B, which is just half of vector B. So clearly these two cancel. Half of an A minus half of an A cancels, so we're just going to be left with half of B. So PQ, which goes along here, is half of vector B. And so from P to Q we've worked out, so we're almost done now, we've done the hard work. We've shown that's half of B, and vector B is from F to E. So we've shown that from P to Q is half the distance from F to E, and we've shown as well, therefore, that the vector from P to Q is half the size of the vector from F to E, because half of B is half of B. So therefore we can conclude by just putting this into words. So therefore because from P to Q is half of the vector from F to E. In other words, half of B is this. From PQ is parallel to FE. We've shown that one vector is multiple of the other. PQ is 2 times FE. So PQ is parallel to FE. So it's shown that FE is double PQ, I mean to say. If you multiply both sides by 2, you get that FE is 2 lots of PQ, but one is double the other. So that's all we need to write. So we've done question 21. Question 22, we've got some circle geometry to consider here. So we've got 2 different diagrams with 2 different circle sections, well, a whole circle B and a circle section A. So it says here about shape A. So shape A is formed by removing a sector of a circle with radius 3x minus 1 from a sector of a circle with radius 5x minus 1. So let's just think about this for a moment. So this line here, shape A, this grey thing, is formed by removing a sector of a circle with radius 3x minus 1, this inner tiny slice there, from the whole sector here, which I'm going to outline in red. So essentially sector, well, this part here A, is formed by taking the whole of the red sector and subtracting from that this tiny inner yellow sector. So that's what we've got there. So the area of shape A is the area of the whole thing minus the area of the small sector. And like the question says here about the overall radius of the large sector has radius 5x minus 1, like so. Now, how do you work out the area of a sector of a circle? Well, we need to consider the sector as being a slice of the whole circle. So a whole circle's got 360 degrees in it, but this sector is only 45 degrees out of a total of 360. Now this will simplify down. 45 3/60ths goes down to 1/8. So this sector is 1/8 of the entire circle. That's the fraction of a circle we're dealing with. So this big sector, the overall sector, is going to be 1/8 of pi r squared, because the area of a circle is pi times radius squared. That's going to be 1/8 times pi times the radius of a big one squared. The radius of the overall big sector is 5x minus 1. So the area of the overall big sector is 1/8 times pi times 5x minus 1, its radius squared. Then I need to minus off the area of the small sector. Now this small sector is also 45 degrees, so this will also be 1/8 of a circle in its own right. So this one here will be 1/8 times pi r squared, but now we're talking about the radius of this smaller one, which is only a smaller radius of 3x minus 1. So that's what we have as an expression. But this also, because we're told in the question, the area of shape A is equal to the area of shape B. So if I just write down here that the area of shape A, which is this, equals the area of B, we can now start thinking about making an equation from all of this, which is what we need to do, because then we can solve it. So shape B is this circle here, and we're told its diameter is 2 minus 2x. But the radius is half of the diameter. So the radius is half of this. Half of 2 is 1. Half of 2x's is 1x. So the radius will be 1 minus x, like so. So the area of shape B, this circle here, is pi times the radius of this circle squared, which in other words is going to be pi times by 1 minus x all squared. So before we get on and start thinking about expanding all this out, let's just be thinking how we can simplify stuff on each side. You can see here pi is a common factor in each term. So what we could do here, we could divide through this whole equation by pi, which will then cancel off these pi's for us. So the pi will disappear from all sides. My next suggestion, to get rid of these awkward fractions, which are at 1/8, we could multiply them through by 8. So if we take both sides and times the whole thing by 8, that'll make it much neater for us. So times by 8, and then times that one by 8 as well. That will then give us 5x minus 1 squared minus 3x minus 1 all squared equals 8 lots of 1 minus x all squared. So as long as we can keep our heads and expand these brackets carefully, we should be absolutely fine and good to go. So we've probably done the hard work now, although there's still some work to be done. So let's see if we can now expand these without getting ourselves into too much of a muddle. So let's expand these brackets carefully. So the first one to expand is 5x minus 1 all squared. So this thing here, if you're going to do 5x minus 1 all squared, best to consider it as 5x minus 1 times by 5x minus 1. So it's this bracket written out twice, essentially. So think of it like this. So 5x times 5x would give us 25x squared. 5 times 5 is 25, x times x is x squared. We can do the boxes in any order using this method. So then we do 5x times minus 1, say. That gives us minus 5x. Over here, 5x times another minus 1 is another minus 5x. And finally, minus 1 times minus 1 gives us plus 1. So overall, this one here is 25x squared. Minus 5x minus another 5x's is minus 10x in total. And then plus 1. Now from that, we're going to minus off all of this 3x minus 1 squared. So we'll think about this minusing all after. Let's just expand this bracket first, then we can think about minusing it all off after. So for this one, again, think of this as being 3x minus 1 times itself. So you might want to do a box method again, like this one down here. So taking this box at the top, 3 times 3 is 9. X times x gives x squared. 3x times minus 1 is minus 3x. 3x times this minus 1, again, is minus 3x. And minus 1 times minus 1 gives us positive 1. So overall, what we've got here is 9x squared. Minus 3x's take away another 3x's. We're taking away 6x's in total. And finally, plus 1 goes here. Finally, this bracket where it's 8 lots of 1 minus x all squared, we can do in a similar way. So 1 times 1 is obviously 1. 1 times minus x is minus x. 1 times this minus x, again, is minus x. And finally, a minus times a minus gives us a plus, so minus x times another minus x will give us positive x squared. So over here, we're going to have 8 lots of 1 minus x minus another x is minus 2x's plus an x squared. So we now need to take a lot of care in terms of getting this neatened up so we can then go on and solve this quadratic. So let's think about here the x squared terms. 25x squared minus 9x squared gives us 16x squareds. Now, the x's, this is where it gets a bit tricky. We've got minus 10x, but we're minusing a minus 6x. If you minus a minus, that gives us a plus. So these 6x's, because we're minusing them, we get a plus 6x from this bracket. So minus 10 plus 6x overall is minus 4x's. Because minus 10 plus 6 takes us to minus 4. Now we've got this 1, and we're minusing a normal 1. 1 take away a normal 1 cancels. So over here, we just get 16x squared minus 4x. On the other side, we just need to take all of this stuff and multiply it through by 8. So 8 times 1 is obviously 8. 8 times minus 2x is minus 16x. 8 times x squared gives us 8x squareds. Now what we can do is try to get everything onto the other side of the equation. So my first suggestion would be to subtract 8x squared from both sides. You can do it in one go if you want to. I'm just going to show you how to do it step by step. First of all, just take off 8x squared from both sides. If we do that, the 16x squared becomes 8x squared. Still got about minus 4x there. Over here, we're going to have 8, take away 16x, and those 8x squareds have now vanished because we've taken them all away. The next step, we can now add 16x to both sides. And if we do that, we're going to get over here 8x squared minus 4 plus 16x's overall gives us plus 12x. And on the right, we'll just be left with the 8. If we now take away 8 from both sides, we'll now have it in a quadratic where it's all equal to 0, which is what we want. So now we have 8x squared plus 12x minus 8 equals 0. Now, before we go on and try and maybe factorise this, big clue, if it's a non-calculator paper, which this is, and you've got a quadratic, likelihood is it's probably going to be factorisable. But here, can we divide through all these numbers by anything? Well, 8, 12 and 8, we can all divide these by 4. So if we divide the whole thing now by 4, don't forget to divide the 0 by 4. I'm half joking, it will make no difference. But you do perform the same operation to both sides. So then what we're going to have is 8 divided by 4 gives us 2x squareds. 12 divided by 4, that leaves us with 3x's. Minus 8 divided by 4 gives minus 2. If you can now factorise that and solve it, you're done. At this point, I'm going to use my own method in terms of factorising this quadratic. Now, if your teacher shows you a different way, or you've got another method, use whichever way you want to at this stage, as long as it works, of course. What I suggest you do, what I show my classes to do typically, is you take this 2 here, and we slide it over and multiply by the very end number. Then, temporarily, we forget about this 2. So I'm just going to rewrite this quadratic as 1x squared plus 3x, and minus 2 times this 2 and moving becomes minus 4. I now factorise this in the normal standard way by thinking of 2 numbers that multiply to give minus 4, but when added together give positive 3. With a bit of thinking, you should come to the conclusion those numbers are positive 4 and minus 1. However, of course, that 2 we forgot about. It comes back now. We divide, if we can, each of these numbers in the brackets by this number we forgot about for a moment. So this 2 we put over the 4, underneath the 4, we put it underneath the 1. Now, if we can divide, we just do. So 4, if we divide that by 2, we can. So that becomes x plus 2. Can we divide 1 by 2? We can't. Does a half simplify down? No, it doesn't. So what we do now is we move this 2 next in front of the x. So you have 2x minus 1 equals 0. So what are we trying to find out for x? What is x? It's easy to forget what you're actually doing here. So what is x? Well, x is essentially a length here. So find the value of x. If you look at this, it means 2 times x. So 2x is a length, so x has to be positive. You can't have a negative length, it doesn't really make any sense. So because we're after a length, a positive value here, we are only thinking about the positive possible answers for x. So therefore, what I'd normally say we do is we take these numbers here or here and switch the signs of these numbers in the brackets. So x will be opposite of plus 2, which is minus 2. So can the length be negative? It can't, so like I said earlier, we reject this solution. The second one will make sense. So this one here, x will equal So of being minus a half, x would be plus 1/2. If this bracket's equal to 0, x would have to be 1/2. So x as a half is our solution to that question. Just one more question to go, then the whole paper's completed. Question 23. So there's 4 types of cards in a game. So each card has either a black circle, a white circle, a black triangle, or a white triangle. What we have to do is express the total number of cards with a black shape as a fraction of the total number of cards with a triangle. And we have some ratios here for extra information. So let's take these step by step. Let's just think about this first ratio. So we're told the number of cards with a black shape as a ratio to the number of cards with a white shape is 3 to 5. So 3 parts black to 5 parts white. Let's think of this as a picture. So 3 parts black, 5 parts white. That's 8 parts in total. You can hopefully see here that 3/8 of these cards have a black shape. Thinking of this ratio next. Number of cards with a circle as a ratio to number of cards with a triangle. We're told that's a ratio of 2 to 7. So for every 2 lots of cards with a circle, we've got 7 lots with a triangle, which we can picture like this. 2 circles for every 1, 2, 3, 4, 5, 6, 7 triangles. The triangles may or may not be green. I'll just colour them in green so they stand out a bit. So, like I said earlier, you can think of this as fractions now. So what fraction of the shapes are black? Well, 3/8 of the shapes are black. And also, thinking separately in terms of types of shape, what fraction of the shapes are triangles? Well, there's 7 out of 9 lots which are triangles, so 7/9 of the shapes are going to be triangles. Next, we need to take this awkwardly worded bit and translate it into some maths we can actually do. So what we're needing to do next is express the total number of cards with a black shape as a fraction of the total number of cards with a triangle. Well, imagine I said to you, there's a class of 30 students and 19 of those students are boys. So what fraction of the class are boys? It'd be 19 out of 30. Why am I mentioning this to you, you might be thinking? Well, whatever number comes after the fraction of goes on the bottom of the fraction. So if a class has 30 people, 19 are boys, I ask you what fraction of the class, of the 30 are boys, put the 30 at the bottom. So translating this into a fraction here, we want the total number of cards with a black shape on the top of the fraction, and because after the fraction of bit is the triangles are going to go on the bottom of the fraction. So taking this and putting it into a fraction gives us this. So 3/8 of the shapes on top, that yellow is a fraction line, over 7/9. So it's 3/8 of the shapes over 7/9 of the shapes. So it's 2 fractions embedded within a fraction in its own right. So this is just looks pretty nasty, pretty awkward. So we need to try and simplify this, and there's 2 main methods we could employ. So method A, method B. So method A, I'm just going to do this as a direct fraction division. So we've got 3/8 over 7/9. One fraction over another is the same as saying that's one fraction, 3/8, divided by the one it's been put on top of. So that's the same as saying 3/8 divided by 7/9. If you're not liking method A, bear with me or skip ahead to method B. So we can do this as a fraction divided by a fraction, as long as you can remember how to do one fraction divided by another. We keep, we change, we flip. We keep the 3/8 the first fraction as it is, we change the divide to a times, we flip the last fraction on its head, so 7/9 becomes 9/7. We now multiply the tops together and then multiply the bottoms together. So 3 times 9 gives us 27, and 8 times 7 gives us 56. And that is our final answer. However, like I said before, it might not be a method you like, so I'll show you method B. It might be easier for some people, for you for example, if you're listening, to think of 3/8 and 7/9 as actual numbers. So could you think of a number to make it feel like it makes more sense, that you can split into eighths and you can split into ninths? If a number can be split into eighths and split into ninths, we need to think of a number that's divisible by 8 and 9. So what number is divisible by 8 and 9? We could think of that in terms of a number that's in the 8 times table and in the 9 times table. If you're not sure what number's in the 8 times table and the 9 times table, simply you could guarantee to find a number that fits by doing 8 times by 9, which is 72. So think of what 3/8 of 72 is as a fraction of 7/9 of 72. To find 1/8 of a number, we divide it by 8, and to find 3/8, we'd multiply by 3. So we do 72 divided by 8, then times by 3. Likewise here, to find 1/9 of a number, we'd divide the 72 by 9, but because we want 7/9, we then multiply it by 7 after. So what we're going to do here, 72 divided by 8 is 9, times it by 3 is 27, then 72 divided by 9 is 8, and then 8 times 7 is 56. So we get the same answer, just using a slightly different method, but either way round we get 27/56. That concludes the paper and all of the questions. So I know it's been a hard slog, but I do hope you found some of those question explanations useful. Please do like and subscribe. Thank you very much for your time, and hope to see you again very soon indeed. So take care for now, and for me, it's goodbye.